All right, here's your first video, 1.1-2, points, lines, and planes. So let's take a look at this. It says, make the figure at the right with a pencil and a piece of paper. Is the figure possible with a straight arrow and a solid board? And explain. So let me think, how am I going to get that arrow to go through a solid board in two places like that? Do you think it's possible? Well, I'm going to tell you, it's not. The only way that this could be possible is if you could bend that board in some way, but it sure looks possible. All right, the first thing we're going to do now, if you've printed your notes, here's what you're going to start filling out. A point. Let's talk about a point. It indicates a location and has no size. So I want you to think about the coordinate plane, the x and y. This is x and this is y. Okay? And now let's talk about a point. So if I have a point right here, let's say this is point A. That's a point. You represent a point with a capital letter. All right, moving on to lines. Lines. It's just a straight path that extends in opposite directions. Okay, so when we think about a line, here's a line, and let's just throw some points on here. A, B, and C. Okay, now with this line it says, how do you name it? By any 2 points. So I can take any of these 2 points. So maybe I'll go A, B, and then you put a line over the top. Or it could be B, C with the line over the top, or A, C with any of those will do it. Now points that lie on the same line, A, B, C, are called collinear. So A, B, and C are collinear. It means they lie on the same line. Now let's talk about planes. All right, so let me draw myself a plane. Here we go. Remember I said my drawing skills aren't so great. And it says a flat surface that extends without end and has no thickness, contains infinitely many lines. I want you to think about this plane, this flat surface like a piece of paper that just extends forever and ever and ever, all the ways. You name it by either a capital letter, so let's say this is plane Z, okay, and then you would say, or, you know, if we have some points on here, let's say points A, point B, and point C, you can say this is plane Z, or you can say plane A, B, C. Okay? Now, points that lie in the same plane are coplanar. So, A, B, C are coplanar. And remember before we said that points that lie on the same line, okay, a point that lies in a line on the same plane are called collinear, because we said that points that lie on the same line are collinear. All right, moving on. We're going to do problem number 1. It says naming points, lines, and planes. What are 2 other ways to name QT? So we've got QT right here, okay? What are 2 other ways to name this line? Another way we could name it is, how about going TN? So we could name it TN and then put your line over the top. Or we can go from T to Q. So we can also name it TQ. And put your line on the top. What are 2 other ways to name plane P? All right, well, there's a lot of them, but we could say that it's plane RQV. RQV, okay, because those are all the planes that are on there, or all the points. Or we could say plane RSV. All those points are on that plane. Okay, what are the names of 3 collinear points, and what are the names of 4 coplanar? Let's go collinear first. Okay, the names of 3 collinear points are right here on this line, and they are R, Q, and S. Those are collinear. Okay, what are the names of 4 coplanar points? That means they're points that just lie on the plane. And coplanar are going to be R, Q, S, and V. All right, it's your turn, so stop this video and give it a go and see if you can get it right. Here you go. I hope you did good. If not, make sure you ask me questions. All right, now let's talk about a segment, part of a line that consists of 2 endpoints and all points between. So for a segment, it has end points. Let's call it RS. And to name it, you name it by its 2 end points. So I would name it RS. And then you're just going to draw a little segment on top. Okay, now let's talk about rays, part of a line that consists of 1 endpoint and all the points of the line on the one side of the endpoint. All right, so with a ray, what you want to think about is kind of like an arrow. It starts somewhere with an arrow on the end. We're going to call this, let's see, A. And in order to name a line, you've got to have 2 points. So let's just put another point on there. And so if I was going to name it, you put an end point and then another point that is on the line. It's very important that this first one is your end point because it tells you where it starts and then which way it's going. You would not want to say BA. That's not correct. All right, opposite rays. Opposite rays, 2 rays that share the same endpoint and form a line. Okay, so opposite rays would be, let's say I've got this ray, which is U, and I'm going to name that V, and then I have another ray, and I'm going to name this T. All right, so I've got 2 rays here. They share the same endpoint, and they go opposite ways. How to name it? By their shared endpoint and any other point on the ray. So I could say, okay, I've got UT and I've got UV. Okay, notice that I always start at the end point and then go to the other point. Okay, now we're going to talk about postulates and axioms. They're accepted statements of facts. Okay, so our first postulate that we're going to talk about is postulate 1-1. And it says, through any 2 points there is exactly 1 line. Through any 2 points there is exactly 1 line. There's no way I could go through those 2 points and have more than 1 line. The next postulate, which is postulate 1-2, says 2 distinct lines intersect in exactly 1 point. So that means if I have, let's say, this line here, and we're going to call it A, B, and then I have another different line, let's call it this line here, okay, and we're going to call this D and E, okay, they intersect at exactly 1 point. We'll call it point C. There's no other way they can intersect in more than 1 point, otherwise they wouldn't be lines. All right, and our next postulate is 2 distinct planes. Again, remember planes. Planes are like pieces of paper. They would intersect in a line. So I went ahead and put a picture up because I can't draw a plane. But if you'll notice, you've got this one plane here, the blue plane. So this is a plane, and of course it's going to extend forever and ever on all ends. All right, and then we have another plane, and we've got this yellow plane. Here's our 2 planes, and where they intersect is right here. And it forms a line right where it intersects. That's exactly what they're talking about. All right, let's do problem number 3. Okay. Problem number 3 says each surface of the box at the right represents a part of a plane. what is the intersection of plane ADC and plane BFG? All right, here's where I get the color. So I'm going to do one of them yellow. I'm going to do ADC. Let's see, that's this plane right here. That plane is ADC. And let me pick another color. Let's do light blue. Okay, and the other plane is BFG. BFG, that's this plane right here. Okay, and then we want to know what is the intersection of them, of those two problems. And so if you look at it, your intersection is right here in the middle. So your intersection is going to be BC. And remember, planes extend on to infinity, so therefore that intersection is going to be a line. It's going to extend. All right, it's your turn, so go ahead and turn this off, or stop it, actually. Give it a go, and I'll put the answers up. All right, there's the answers. Now, do I expect you to know postulate 1-3 and postulate 1-1? No, I expect you to understand that postulate 1-3 says that two planes intersect at a line, and that postulate 1-1 says that a line contains infinitely many points, but we really only need 2 points. All right, so now another postulate, postulate 1-4, and postulate 1-4 says there's only one plane through any 3 non-collinear points. So let me draw my plane. Here's my plane, okay? And if I say, and we're going to call it plane P, and there's only one plane through any 3 non-collinear points. So if I have 3 points, A, B, and C, there's only one plane that contains all of those 3 points. I cannot have another piece of paper somewhere around there that would have all of those points on it. All right, problem number 4, using the postulate 1-4. What plane contains points N, P, Q? All right, so let's think. Here's N. Oops, where'd my N go? Okay. Here's N, here's P, and here's Q. So if you look at that, the only one that contains all of those points is this bottom plane. So the bottom plane. All right, now what plane contains points J, M, and Q? Let me pick another color. Okay. J, M, and Q. J, M, and Q. Well, we don't have any sides here, but what we could say is it would be the slanted plane inside of here, inside that box. Okay, it's that slanted plane. So it's the slanted plane. Even though it's not drawn, but there is a plane there. All right, finally, it's your turn again, so turn this off or stop this and give it a go, and I'll put the answer up. Okay, what planes contain LMN? It would be that red slanted one that goes from the side KL to NP. It like cuts that box in half. And the B, what is the name of the line that is coplanar with JK and KL? JK and KL. So those are on that plane. So it would be JM. Or not JL. What am I thinking? Or ML. Those guys, those lines are all coplanar with JK and KL.